Planetary diversity, rocky planet processes and their observational signatures. A new text for interdisciplinary researchers engaged in the characterization of the nature of planets and exoplanets. To date, we have discovered many planets beyond our Sun whose size is similar to that of the Earth. However, it seems very unlikely that this similarity would extend beyond the bulk mass or radius of these new worlds. Orbiting around stars with different chemical abundances compared to our Sun, these exoplanets may have rocks formed with quite different compositions compared to those commonly found on the Earth. The planet may also acquire a smaller or larger internal heat budget from varying abundances of radioactive isotopes or from a different collisional history. The amount of volatiles is also highly unlikely to be a constant, depending on factors varying from the planet's formation location relative to the snow lines in the planet-forming protoplanetary disk, through to the architecture of the planetary system itself. Variations in the rocky composition of the planet change which minerals are formed in the crust and down through the planet mantle. This affects properties such as viscosity and how easily heat is transferred from the planet's centre up to the surface. This can impact the formation and properties of the planet core, which in turn impacts the generation of the planetary magnetic field. A weaker magnetic field can boost atmospheric loss due to interactions with the stellar wind. Such loss may also be strongly impacted by the atmospheric composition. The planet's lithosphere, comprising of the crust and uppermost mantle, may form a relatively rigid stagnant lid, or something more mobile. On Earth, the lithosphere is broken into discrete blocks to form our planet's tectonic plates. Which of these occurs will strongly impact heat circulation through the planet and affect processes such as volcanic outgassing and hence atmospheric evolution. As we enter the next era for exoplanet science, where telescopes will not just detect the planet's presence, but also aim to measure their atmospheric composition, understanding how these processes occur and connect will be vital for deciphering how the gases in the atmosphere relate to conditions on the planet. Moreover, without a thorough understanding of the abiotic processes a rocky planet can manufacture, the hint of life will be impossible to determine. This volume considers how a planet similar to the Earth will change under variations of magnetic field strength, internal heat budget, composition, and volatile abundance. The book is aimed at researchers exploring the potential diversity of rocky planets and the characterization data from our upcoming generation of instruments aimed at worlds beyond our Sun.